Eisenhower's up here. We'll go over these answers. When it printed out, something happened to it. But we are going over the answers to the writing inequality sheet. For number 1, this is y. I don't know if you're doing it. Y is greater than negative 4x. That should be plus 2. Printed out here.
So that's plus 2.
It should be plus 2. I don't know why I did that. Okay, so y is greater than negative 4x plus 2 was number 1. Number 2 should have been y is less than x plus 5. Questions on those two? Number 3 was y is less than negative 3. And 4 was x is greater than 0. So all of those should have been a less than or a greater than, not an equal to. For the next 4, five was y is greater than or equal to negative 4x minus 5. 6 was y is less than or equal to negative 7/3 x minus 3. 7 was x is greater than or equal to 0. And 8 was y is less than or equal to 4. Yes, wait till the bell rings. The first bell rings. Yes. Yes. Do we have questions on any of these? Okay. At some point today, you need to finish that activity and turn it in if it's not already. If it's finished, you can go ahead and turn it in now. So the same thing that was on your graphing linear inequalities is up here. So that means we're going to do the same thing. Remember that system means more than one, so we are now graphing 2 of them on the same graph. Everything that we were talking about with inequalities, if it has a less than,
Just me to do it. Not you.
Take those out. Thank you. If it's less than or greater than, you're still using a dashed line. If it's greater than or equal to, less than or equal to, you're still using a solid line. We're still shading above if it's greater than or equal to. We're still shading below if it's less than or equal to. So think about when we were graphing systems, we'd have 2 lines on the same graph. Now we're going to have 2 inequalities on the same graph. So we're going to have shading that overlaps. So for number 1, actually let's do number 2 just because that one has something that's a little off. For number 1, I'm going to graph these in different colors. If you would also like to graph them in different colors, there are colored pencils in the colorful card and highlighters up here. If you are just using your pencil for both, make sure they're shaded in 2 different directions. You'll see what I mean by that in a second. So for the first one, we would start this off by starting at positive 8. Our slope is 1, so we're going to go up 1, right 1, as many times as we can.
Say up one, right one.
Up 1, right 1, or down 1, left 1, as many times as we can. Jay, if it's hard to see from there, you can move your desk up. Would this be a solid or a dashed line? So not solid, it'd be dashed because it doesn't have an equal to. I don't have the space to do that, so I'm just going to make it a dotted line and draw arrows. Would this be shaded above this line or below it? Above. Why would it be above? Because it's greater than. Okay. For your second line, so I'm kind of going to disregard that I already drew one and just draw the second one as if it were a new line. I'm going to start at -6. And you have a negative slope, so go up 11 and left 3, because I can't go down and right.
To the right.
Left 3. Will this be a dashed or a solid line? Solid, because it's or equal to. And would we shade above this line or below it? Below it. So your shading is going to overlap. So when you graph your system, you're really looking for the section where they overlap. So all of your solutions would fall in this area, not in the other two. I'm going to outline this. And we'll talk about more solutions here in a second. What questions do we have on this right now? So not much has changed. You're still doing the same things you were doing while you were graphing. You are now just graphing 2 of them, which means you have to remember which ones are dashed, which ones are solid, which ones are shaded above, which ones are shaded below. I want you to try number 1. So try number 1 and then we'll go over that one. For 1, start at -7. You have a negative slope, so go up 1, left 5, as many times as you can. Down 1, right 5, as many times as you can. That line should be a dashed line. And it should be shaded above. your second line should start at +1. You still have a negative slope, so go up 9 and left 5. If you can go down 9 and right 5, do that too. What you should be noticing is that they intersect at some point, just like systems do. But that's not your solution. Or if it is not your only solution. This will be a solid line. Mine's a very crooked solid line, but that's okay. And we're shading above this line. But this entire section where the second line was is our solution area. And sometimes that happens. Sometimes one line kind of overpowers the other one. Takes up more of its space. Do we have questions on number 1? Does everyone's graphs look like that? Yes. Did you draw negative slopes or positive slopes? Yeah, so you drew positive slopes. So make sure you have negative lines if the slopes are negative. Okay, let's do 3. For x is less than 5, is that going to be a vertical or a horizontal line? Vertical. Will it be dashed or solid? Dashed at 5. And would this be shaded to the left or to the right? To the left. So if that is confusing, think about what numbers would be less than 5. And all of these numbers would be that. Bishop, put your phone up. Okay. Now the other one we need to solve before we graph. So subtract 7x. Divide by -5. What happens when we divide by a negative? The sign changes. So now we have y is less than or equal to +7/5 x plus 1. Everything has changed. So starting at +1, going up 7, and right 5, and then down 7 and left 5. Will this be a dashed or a solid line? Solid. Shaded above or below? Below. So in this case, this triangle right here is your solution area where they overlap. So there is only one way to solve systems of inequalities, graphing. So we should not be trying to solve them any other way but graphing. And now we're going to go back to this. Determining which solutions are solutions for this system. Yes, you can still do this part algebraically. You could put -2 in for your x's, -2 in for your y's, and see is it true for both. And you can also graph it. So I'm going to graph it and then we'll talk about how to do that algebraically. So in this case, add 3x to both sides and divide by 5. Y is less than 3/5 x plus 2. We don't need to solve our second one because it's already solved for us. Let's go ahead and graph both of those. So starting at 2, going up 3, right 5. And then go down 3, left 5. As many times as you can. Would this be a solid or a dashed line? Dash. Shaded above or below? What did you say? Below. Because it's less than.
I think that's not right. The slope is negative.
So when you move this to the other side, you add it.
But wasn't what?
When you move this, you added 3x, you didn't subtract.
I'm confused.
On which part?
Um,
What does your equation look like?
the same thing, just with negative.
Yeah, so it shouldn't be negative because it was already negative. So when you moved it, you added. So it'd be positive. So it shouldn't be negative. No, the second one is. So start at -5 and go up to left 1 as many times as you can. And down to right 1. Would this be a dashed or a solid line? Solid. Shaded above or below? For this one, since it's greater than, it'd be shaded above. So now let's find our solutions. Of course, I can't see my lines anymore, so those colors would probably be benefits. But -2, -2. I think that's here. You can see that. Would that fall in your solution area? It has to be in the solution area that overlaps. If it's not a solution. 1, -1. Let's see if I can accurately do this. Would that be in the solution? Yes. 1, 1.
Yeah.
Yes. 2, 5. Let's see. 1, 2, 3, 4, 5. No. 6 zeros. So 1, 2, 3, 4, 5, 6. Yes. Now, what if I added in another point? Let's say I chose whatever that point was. 0, 2. What do we think? Why no?
Because it's not falling inside the area.
Okay, but before when we were talking about equations or inequalities on the line, if they were on the line, we could say yes or no.
It's because it's not greater than, it's not greater than equal to. Yeah, like greater than equal to. Since like it's not a dash line, if it was on the line, it wouldn't be because it's not greater than equal to.
Okay, so you're saying because this is a dashed line, it's not. But what if I chose, what was this line up? 0, -5. So Kayla said it would be, but I want us to show this algebraically. So let's put this into our equations. So put 0 in for x and -5 in for y. Test this. Does this work for both? So I see a lot of eyes just staring at the board, which is fine if you're processing, but you should also be writing. Is this true for both? Is -25 less than 10? Yes. Is -5 greater than or equal to -5?
Yes.
Yes. So yes, in this case, this worked. For every point that lies on a line, you need to be thinking of two things. Is it included, meaning is it dashed, is it solid? But also, you need to check this. That's the second thing you should be thinking. I need to check this because this happened to work. Most of the time it won't work, but there is the occasional it will. When you have two solid lines, it will always work because they're both included. If you have two dashed lines, it will never work because they're not. But when you have one of each, you have to check because it could be a solution, but it could not because one's included and one's not. So you always need to check those. Do we have any questions on this piece? For this last page, you are taking what we already did, writing your linear inequalities, and stating a solution that would fall in the shaded area. So let's do a couple together and then I'll let you try some. For my blue line, you can color them differently if you so choose. For my blue line, would this be greater than or equal to, less than, or less than or equal to? How do you know that? So it has nothing to do with your slope. It is a solid line, so it's equal to. How do you know it's less than? Because it's below. So right now we know this much, that this is less than or equal to. Now we need to find our slope and y-intercept. What is the slope of this line? Negative x, negative 1, and then x. Your y-intercept? Plus 4. Right? Of my purple, pink, whatever color you see line, will this be less than, greater than, less than or equal to, or greater than or equal to? Why do you say that? Because it's above and it's dashed. Okay. What would your slope of this line be?
-2.
So that would be your y-intercept. But your slope here is 1. You're going up 1 over 1. So those would be your two inequalities. You've now created your system. Give me one solution that would fall in your solution area.
0, 0.
0, 0, negative 2, what? Negative 2, 0. You could name me a bunch. As long as it falls in the area where they both overlap, that's fine. If you cannot see the shaded on any of these, just make sure you copied that down. Yes. So in 1 and 2, they've basically taken out the others, like the original for one and the original for the other. They just put the overlap. But for 3 and 4, you can see both. For your red line, would this be less than or equal to, greater than or equal to? For your red line. Greater than, because it's shaded above this line, and it's a dashed line. What is the slope of that line? Negative 1, and then x. And your y-intercept? -1. And then of your blue line, Is this greater than or equal to, less than or equal to? Because it's a solid line and it's shaded below. What is the slope of that line?
So is number 2 just blank?
Oh, can you not see it?
We can't see number 2 now.
It's shaded.
Okay.
What is the slope of your blue line?
2/3 x.
2/3 and then x. And your y-intercept? Plus 3. What would be a solution for this? 4, 0 would be a solution. Really anything in this area where they overlap. Okay. Take a second and do 3 and 4. If you're still working on those two, that's fine. I'm going to go ahead and put the answers to these two up. I'll scroll back up here in a second.
No, wait.
Alright, the equations for number 2 were y is greater than negative x minus 3. Y is greater than or equal to 2x plus 3. Give me a solution for that one. 2, 3. Would 2, 3 work? It was negative 2, 3. Negative 2, 3 would work, yes. And then your two equations for 4. Y is greater than 2x minus 3, and y is less than or equal to 4x plus 1. Give me a solution for that one. 4, 1? No, 1. 1, 1. 1, 1 would work. You gotta be very careful with that one because it's a very small area. Okay? The last thing I'm going to show you about systems is how to do it in your calculator and then how to do it in Desmos. So if you do not have your calculator, go grab it. And we're just going to use two random, we can actually do this one. Number 1 on the paper I just gave you, we're going to use those two in your calculator so you can see what that looks like. The directions to that is on the next page. So if you get lost, they are on the next page. Before you do anything else, reset your calculator. Second plus 7, 1, 2. For inequalities, in order to graph them, you need to go into apps. Now, I have a lot more apps than you do. What do you think we're looking for? N equals. So go to N equals and press enter. Apps.
It says it on the.
There's a button that says apps. Oh. This screen should pop up after you've turned N equals on.
I just has 4.
Yeah, yours won't have as many as mine. It's because mine is the computer version. Okay. Go into y equals. Nothing really looks different. Hold on. Let me change this so that mine actually looks like yours. Because right now mine doesn't. Okay. Alright, so when you go into y equals, this is what you should see as you hover over the equals. That means you can change it to whatever you want, whatever inequality sign you want. So let's put in number 1's inequalities. In order to hit these buttons, you need to hit the buttons at the top. So each one goes with one of them. To get greater than or equal to, we need to hit graph. Oops. I need to save on yours. Okay, alpha graph, sorry. Alpha, whatever button you need, and that will change it. When you do that, you should see this change. What did you say? What did you just do? I pressed alpha graph. And then you can put in the rest of your equation. The bad thing about this app is that you cannot put in fractions while you're in equals. So you'll have to use parentheses if you have fractions. Negative 3x plus 3. And change your other one to just greater than. So you need trace, alpha trace. If you're looking at these, they should look different. One should be a solid line shaded above. One should be a dashed line shaded above. Yes. Yes. So you can't put in alpha y equals in this, so you'll have to use parentheses. And then once you have both of those in, you can graph it. And it's going to do this weird thing. One, it's kind of difficult to see both of those. So if you go into Shades Alpha window, you'll get three options. You can see their intersection, their union, or their original shade. So what we see right now is the original shade. Just so you see what each one looks like, you can go to 1. And that's like where they overlap. I'm going to go back and go to 2. That's everything. You don't want 2, don't use it. 3 or 1. So if you just need to shade the part that they overlap, 1 is your go-to. If you want to see both so that you can graph both, go to 3. Do we have questions about the calculator portion? Did you have a question? Inequalities, and the only thing you can do is graph. That means if you do it on your calculator, if you do it on Desmos, you have to show me the graphs, no matter what. For number 2, I'm going to put both of these in here on my computer. So in a second, I'm going to let you grab your phones so that you can see this and you can do it. You can either type in the inequalities, so if you're on your phone, you have the less than, greater than symbols. But in the keyboard, you also have the rest of them if you need them. With Desmos, it graphs your inequality for you automatically. So in this case, I can see that everything over here would be my solution area, because that's where they overlap. Questions on that? So whether you're using your calculator, doing it by hand, or doing Desmos, you have to show me the graph in one of those ways. Okay? So for the rest of class, you can work on that homework. If you don't finish it, it is homework.
This is homework?